In what are the units in which we will be measuring the areas?
Square feet. Square.
Hmm? Square.
Meters and centimeters.
Feet, sir. Feet, sir.
Meters and centimeters. Meters and centimeters are linear units, not area units.
Feet,
What
sir.
are the various other units?
Acres. Hectares.
Feet, you can measure the area. Hectares, okay. Centimeter square and meter square.
Integration.
Sir,
It's
yards.
not only centimeter meter, it's squares. Okay. Or yards, fields. So basically, there are two systems of measuring units. One is British units. Okay. Another is the metric units, where in British units will be measuring the areas, given areas in square feet and acres, whereas in metric units will be measuring the areas in square meters or square kilometers or hectares. Okay. So 1 square kilometer is equal to how many hectares? Mere wild guesses. I hope you know one meter is equal to 100 centimeters, 101 meter is equal to all those things, right? Let's talk about only in the form of hectares, acres, and square kilometers, which is generally used for measuring the areas. So 1 square kilometer is equal to how many hectares? And 1 hectare is equal to how many acres? 1 acre is equal to how many square meters? I want the answer for this. And 1 acre is equal to how many yards?
1 hectare equal to 10,000 meters square, sir.
1 hectare is equal to 10,000 meters square. Okay. 10 to the power of 4 meters square. Okay. 1 hectare is equal to how many acres? So as a civil engineer, you need to have an idea of this. 1 square kilometer is equal to 100 hectares. 1 hectare is equal to 100 acres. 1 acre is equal to 100 square meters. Or 1 hectare is equal to 10 to the power of 4 square meters. Whatever it may be, the unit conversion you can do once you know the relation between meter and kilometer, all those things. Okay. But most of the cases will be measuring the area in acres or hectares. If you're talking about the city, the area of the city, the larger areas will be mentioning it in the form of square kilometers. But if you're talking about the agricultural land, it will be in the form of hectares or acres. And if you're
Acres.
talking about the individual plots, residential plots, it will be in the form of yards. That is the general notation which we are following in the industry or in the field or in general. Okay. If you ask what is the plot size of your home, you will say it has 220 yards or 230 yards or 250 yards. If you say how much land you're having, say 1 acre or 2 acre or 10 acres, sometimes hectares. Okay. If you say what is the area of Hyderabad city, 650 square kilometers or 660 square kilometers. What is the area of Delhi? 100 square kilometers, like it will be saying. So you can use any units, not a problem. But as per the standards established by India, we need to use the metric units because we are following the SI system. So mostly it should be in the form of square meters and hectares in all official Sometimes we also mention, though we use SI system in metric units, sometimes in brackets, we will also mention in the British units, that is in the form of acres or yards, because that is the most, what we can say, easily understood by the public, general public. If I say that I'm having 10 hectares of land to a normal people, what he will think? He'll think that we are telling acres as hectares, but there's a difference between a hectare and acre. But if I say that a person is having, a farmer is having 5 acres of land, you will be able to understand and you'll say that on నాకు 5 ఎకరాల పొలం ఉంది అంటాం. But if I say 5 hectares of land, you can see there the number changes. Okay, because 1 hectare is equal to 100 acres అన్నప్పుడు 5 acres is equal to how much?
500.
1 hectare is equal to 100 acres అన్నప్పుడు 5 acres ఎంత? 1 by 100 into 5 ఎంత? 5 by 100 0.05. Okay, so it is 0.05 hectares. If you say that if you go to a farmer and say that you are having 0.05 hectares of land, దెబ్బకి గుండెపోటు వస్తుంది వాడికి. 5 ఎకరాలు ఉన్నదని 0.5 hectares అన్నావు అనుకో, he will think that you are talking about his land in acres. No, I have 5 acres. He'll fight with you that I'm saying I'm having 5 acres, but you will be talking in the form of hectares. So there will be a big problem in that cases. So you need to be very clear. If you are preparing a technical report, you need to represent it in the form of an SI units. But if you are dealing with the general public, then you need to be prepared yourself with the units which those people are comfortable with. Okay? So how do we measure these areas, or how do we calculate these areas? So there are basically 3 methods. One is analytical method, and graphical method, and mechanical method. Where analytical method involves measuring the areas directly from the field measurements. In the field, what you'll be doing is you'll be measuring what is the length of the line, what is the angle between 2 lines, and by using some geometrical equations and trigonometric equations, you'll be determining what is the area. Okay. And the graphical method, the outline of the plot is divided into set of triangles or trapezoids or rectangles or any regular geometric figure. And once you divide the given area into set of triangles, etc., kind of thing, you can simply determine what is the area using your half into base into height equation, or taking the average of 2 opposite sides. All those things you can determine by graphical method. And for all irregular boundaries, generally it is not possible for us to determine the exact area. In those cases, we'll be using the mechanical devices such as a planimeter. Okay? We'll be using a planimeter for determining the exact areas. But most of the cases, in whatever survey you are doing, unless and until the land surface is in a regular shape, that is in the form of a square or a rectangle, the other areas which you are calculating is approximate area only. So we try to minimize the errors and try to determine the approximate area with a 5 plus or minus 5% or 10%. Then we'll be saying that the area occupied by this land is some X hectares or some Y hectares, like that. Okay. So today let us see what are the various equations that we'll be using and what are the various other methods that are existing to determine your areas. I hope you all are aware of the equations used to calculate the area when a triangle is given. Can you tell me some equations? When triangles are given, how to calculate the areas? Anyone, please. Huh? Yes, remember
Half into AB into sin C.
Half into AB into
Sin C.
sin C. That is half into 2 sides.
Sin C, sir.
Yeah. Area is given by 1 half into 2 sides multiplied by sine of the opposite angle. Okay. Any other equation? One equation is half into base into perpendicular. Also, you'll be getting the half into base into height. You'll be getting the area of a triangle. Any other equation which can be used?
Under root S
Root
into S
over
minus A, S minus B.
Yeah.
S
Under
minus.
root S into S minus C into S minus B into S minus C. What is S there?
A
How to
plus B
calculate
plus
it?
C by 2, sir. A plus B
A plus C by 2.
C by 2.
B plus C by 2.
So the same equations we are going to use, and we are going to determine the areas. I'll just share that equations to you. So when all sides are given to you, so this is what I said. We will be assuming some obstruction. The area is in this fashion, in an abrupt manner. So we'll be assuming it to be, we'll be assuming the mean line of this area, and then we'll be determining the total area enclosed within this figure. Okay. In that fashion, we'll be doing some assumptions in order to get the area, because it is not possible to divide that area exactly into regular triangles or regular rectangles or other shapes. Okay. So the first basic method is a triangle method. When all sides are known, area of a triangle is given by A is equal to S into S minus A into S minus B into S minus C, where A is equal to A plus B plus C by 2. Okay, and ABC are the lengths of the three sides. So you can determine this. You can use this equation when all the sides are given to you. If only two sides and included angle are given to you, then the area is given by half into AB into sine ACB, that is sine C, or half into BC into sine A, or half into CA into sine B. Any of this equation you can use and determine what is the angle. So what is the area? And if the length of the base and perpendicular are known, you can determine area is equal to half into base into perpendicular. Then how to calculate the area of a quadrilateral? What is a quadrilateral?
Which has four sides.
It has four sides. So how to calculate the area of a quadrilateral?
A polygon which has four sides.
Okay, accepted.
Triangulation method.
Angle or correct angle?
Triangulation, sir. Dividing into
A
triangle.
quadrilateral can be divided into set of triangles, or a polygon can be divided into set of
Yes,
triangles.
sir.
You can see in the first figure, this is a quadrilateral, so I'm dividing it into two triangles. So then I can determine what is the area of this ABC and ACD, and if I add these two areas, I'll get the total area enclosed between ABCD, right? Similarly, this is a pentagon, or we can also call it a polygon. So it is divided into 5 areas: AOB, BOC, DOC, AOE, and AOE. Once you can measure these fields, these lines OE, OD, OC, OB, OA, and AB, BC, CD, then you can apply the equation S is equal to S minus A into S minus B. That equation can be applied. Okay. Or you can drop a perpendicular. This is a quadrilateral. I have divided into two set of triangles. Then I am measuring a perpendicular distance from one corner to the baseline. So if I measure this distance AC and FH, okay, I can determine the area of this triangle half into AC into H1. Okay, similarly here. So the same equations which are applicable for the triangles, area calculations using triangles can be used here also. But only thing is, we'll be dividing the given area, study area, into some set of triangles or set of trapezoids or rectangles or squares, depending on the existing scenario in the field. Okay. So here you can see 1, 2, 3, 4 triangles are there. 4 triangles I can calculate the area individually, and if I sum up all those things, I'll be getting what is the total area enclosed within this boundary. Okay. Here also I'll be getting 5 areas: A1, A2, A3, A4, 5. If I add that, I'll be getting the area enclosed by A, B, C, D, E. Okay. So the simple is, we are going to divide the given area into some set of triangles, and we are going to determine the area of each polygon or each block, and we are going to add all those things in order to get the final area. Then how to determine the area of a segment? Okay. Area of a circular segment is equal to the area of the sector minus the area of the corresponding triangle. Okay, this is the sector ACBO, or AOBC is the sector. Okay, if I want to determine the area of this triangle, what he's saying, it is equal to the area of a sector minus the area of the corresponding triangle. I want to determine what is the area of this circular segment. Okay. So area of segment ACB is equal to area of sector ACBO minus area of triangle AOB. Okay. So area of sector ACBO is pi r square by 360 into alpha, the angle, minus area of triangle AOB is two sides is given as RR. So 1 by 2 into RR into sine alpha. So A is equal to R square into pi alpha by 360 minus sine alpha by 2. I'm just what we can say, reading these equations, because these equations are already studied by you many times right from your schooling. Just you need to remember those equations. Okay. And if you want to determine the area of a parabolic segment, here it is a circular segment. ACB is a circular segment, but if you want to determine for a parabolic segment, the area is given as 2 by 3 into base into height. Okay. 2 by 3 into AB into, this is the height, CM. Okay. So these equations you need to remember. So this is for these equations. Above equations are generally used for straight boundaries where there is very minor irregularities or minor variations. But if you take any land on the ground surface, most of the cases you will be having irregular boundaries. You can take any agricultural land. Do you find the agricultural fields in the rectangular shape or a square shape anywhere? 90%
No,
no.
sir.
Okay? 90% no. Only you will find the other residential plots in a regular shape, because the given the agricultural land which is converted into a residential area, they will divide the plots into equal shapes. Okay, 200 feet by 220 feet by 20 feet or 30 feet by 30 feet length and breadth, they'll divide it, and the rest of the area they will keep it open, or they'll lay the roads or whatever, go for plantations like this. But natural agricultural lands will never be in a regular shape. So you need to assume something, or you need to compromise a bit in order to determine what is the area there. Okay. So when we are having some areas where we are having some irregular boundaries, but which are in straight in nature, then we have some set of techniques through which we can determine. And if the boundaries are not straight, if the boundaries of a given area instead of straight, if they are in a parabolic nature or if they are in a curved nature, we have some set of equations. So we need to first identify we need to first do a survey of the given area and identify whether a particular equation can be applied to that area or not. Okay. So if the boundaries are straight lines, irregular straight lines, you can see here there is a figure. In the first segment, it is increasing. In the second segment, it is decreasing. Third segment increasing. Fourth segment increasing. So when the ground is in this fashion, then there are several techniques, like 3 to 4 techniques, using which you can determine the areas. Okay. So for this, what we'll be doing is, okay, we'll be taking offsets from the traverse line. So assume that this is the traverse line. The bottom line baseline is the traverse line. So we are going to take, so what we'll do is generally when, again, I don't have here. Assume that this is the area I want to delineate. I want to determine the area. So what I'll do is first I'll run first I will run a center line. Assume that this is the area I want to determine. Okay. Then what I'll do is I'll run a center line or a baseline, so that the area is divided into almost equal offs. Okay. Then I'll measure this length, this center line length I'll measure. Then at regular intervals, I'll be taking up the offset of my choice, 5 meters or 10 meters or 20 meters, whatever it may be. Okay. So like this, I'll be taking the offsets. So first I'll lay a center line in the survey area where I want to measure the area of the field. Then at regular intervals of my choice, I'll be taking an offset using a cross affine tape, okay, to the outer edge of the boundary. So what happens here is, once I divide that area into the number of segments like this, I'll be determining what is the length of the mid ordinate at the center of this D. Okay, I'll measure what is the distance from this center point of this D up to this outer end of the boundary. Similarly, in the second portion also, I'll measure what is the distance from the center of this portion to the center of this outer boundary. So like that, I'll be determining what are the mid ordinates. So these are called as offsets or ordinates, and the center ones are called as the mid ordinates. So when I measure this M1, M2, M3, M4 in the field using a tape, and when I know what is the distance between these two successive ordinates or two successive offsets, okay, the area is given by A is equal to D into M1 plus M2 plus M3 plus M4. So if I have 10 ordinates, I'll be getting up to M1 plus M2, M3, M4, M5, M6, M7, M10 up till M10. Multiplied by D is the distance between the two successive ordinates. When the distance D is common, that is when the offsets are taken at a common interval, you will be getting it as D. If you are taking it at different lengths, if this is D and this is D1, this is D2 and this is D3, then D1 into M1 plus D2 into M2 plus D3 into M3 plus D4 into M4 will be the equation. Okay. So this is the first equation, which is called as mid-ordinate rule, which is used to determine the boundaries of the areas of the boundaries with the straight irregular boundaries. Okay. The same equation in general is written as A is equal to D into M1 plus M2 plus M3 up to Mn, where n is the last ordinate, or A is equal to L by n into M1 plus M2 up to Mn, where L is the length of the baseline, the n is the number of segments. That is, this total distance is L divided by, if I take n, I'll be getting the D value. Okay, 1 segment, 2, 3, 4 segments. So here in this figure, n becomes 4. Okay. So this is the first equation or first rule using which you can determine the areas. And the second one is the average ordinate rule. The same fashion, we'll be dividing the area into some set of segments at a distance of D or D1, D2 as per your requirement. And here in the first case, you are going to measure the mid ordinate. At the center, you are going to measure the ordinate. But in the average ordinate rule, what you are going to do is, you are going to measure what is the ordinate one, O1. So at this point, you'll be taking the tape and you'll be measuring what is the distance from this point to the boundary. Again, at a distance of D meters, you'll measure what is the distance from this, what is the length from this point to this point. Again, O3 you'll be measuring, again O4 and O5 you'll be measuring. In this case, what we are doing is, you are going to take the average ordinate, O1 plus O2 plus O3 plus O4 plus O5 by 5. Okay. So the area is equal to average ordinate into L. Okay. In this figure, it is O1 plus O2 plus O3 plus O5 by 5 into L. In general, you can write it as O1 to ON by N into L. Okay. In the first case, you are measuring the mid ordinate and taking the, multiplying it by the length of the segment. And in the second case, you are going to take the average of all ordinates, okay, or all offsets from first point to the end point of the survey area. Okay. So these two, what can be the problem? What can be the disadvantage of these two methods?
ఎగ్జాక్ట్ ఏరియా రాదు సార్,
Exact area దేంట్లో రాదు.
యావరేజ్ దాంట్లో.
We are taking the average values here. So which is better, first one or second one?
ఫస్ట్ వన్స్.
First one is better.
ఎస్.
Why second one is not better? In the first one, you are
average తీసుకున్నాం కదా సార్. సెకండ్ దాంట్లో యావరేజ్ తీసుకుంటున్నాం కదా సార్,
అందుకు బెటరా?
అందుకు బెటర్ కాదు సార్, అందుకు బెటర్ కాదు.
యావరేజ్ తీసుకుంటే బెటర్ కాదా? To take average, then only it's better. In the first case, you're measuring the length at the center and you're multiplying it by D. Okay. But here you're considering both the edges of your boundary, and you're taking the average of the two. So second one is a better option when compared to the first option, because in here, all the exact values or exact offset values are being considered in determining the area. Okay. Here also there is some compromise. But in order to counter that, we have a trapezoidal rule where we are going to determine the area of each trapezoid separately. In the average ordinate rule, you're taking the average of all ordinates. Okay. But in the trapezoid, what we are doing, we are going to determine the area of each trapezoid separately. Okay. So whatever error that is occurring in this trapezoid is limited to only this trapezoid. In the earlier case, whatever error is occurring here, it can happen at any place. because you are considering all the ordinates. But in this case, I am taking the trapezoid, first trapezoid, I am taking the average of the two, O1 plus O2 by 2 into D, and O2 plus O3 by 2 into D, O3 plus O4 by 2 into D, O4 plus O5 by D. Okay. And if I add all those things, I'll be getting A is equal to D into O1 plus O5 by 2 plus O2 plus O3 plus O4. Okay. If you write that in a general form, A is equal to D into O1 plus On, where N is the last ordinate, divided by 2 plus O2 plus O3 plus O4 up to On minus 1. Okay. So this is the trapezoidal method which is generally used in most of the surveying problems to determine the areas. So the statement comes here, the area is equal to the product of the common distance D with the sum of the intermediate ordinates and the average of the two end ordinates. Okay. So you need to by heart this equation or remember this equation. A is equal to D into O1 plus On by 2 plus O2 plus O3 plus O4 plus up to On minus 1. Okay. So this is how you'll be determining the area using trapezoidal equation. Okay. Actually, these derivations are not there for you. That's why I'm not covering as part of syllabus. I'm just giving you the equations based on which you can solve the problems. And if the boundaries are with irregular interval of offsets where D1, D2, D3, D4 are not equal to each other, then the area is given by D1 by 2 into O1 plus O2 plus D2 by 2 into O2 plus O3 plus D3 by 2 into O3 plus O4 plus D4 by 2 into O4 plus O5. Okay. So the assumption in this trapezoidal method is we are assuming that the two ordinates are being joined with a straight line. Okay. That is the assumption. So, but as I said earlier, there can't be a perfectly straight line boundaries in the ground, on the earth surface, or in the agricultural fields especially. So the values which you are going to get this may not be 100% accurate. So in order to counteract that and in order to improve the accuracy of the area calculations, one more rule we have that is called as Simpson's rule, where we are going to consider the curvature of the boundaries. In the trapezoidal rule or ordinate rule, average ordinate or mid ordinate rule, we are assuming that the two edges of the boundary are joined with straight lines. But in order to increase the accuracy of the area estimations, in the Simpson's rule, what we are going to consider or assume is that we are going to assume that the boundary is a curved boundary. You can see here, these are the two ordinates O1 and O2. So it is joined by using a curve, DH. Similarly, we are having two ordinates O2 and O3. They are joined by using HF, which is a curve. In the earlier case, what happened? We have just drawn like this, a straight line, like this, we have drawn a straight line. But here we are assuming the curvature. Okay. So this curvature is assumed to be a parabolic arc or of parabolic nature. Okay. So the area now between this figure is calculated in the below fashion. Okay. Area between line AC and curved boundary DHF. This is my actual area which is being represented in the field. Okay. This is equal to the area of the trapezoid ADFGFC plus area of the segment DHFD, this portion. So what I'm doing, I'm simply dividing this curved boundary into two portions. One portion is the trapezoid ADFC and the other portion is parabolic segment DHFE, this portion. Okay, if I add the areas of these two, then I'll be getting what is the area enclosed by ADHFC. Okay. So let us assume that O1, O2, O3 are the consecutive ordinates at regular intervals of D. So area of trapezoid ADFC is given by O1 plus O3 by 2D. O1 plus O3 by 2 into 2D. The distance between these two is 2D. Okay. And area of segment DHFE is given by area of parabolic segment is 2/3 of area of parallelogram. G, you can see here we are having a parallelogram. I'm just extending this point D to G, extending this point F to J, and I'm joining the line GH passing through H. So it becomes a parallelogram. Okay. So the area of a parabolic segment is equal to 2/3 of the area enclosed by this parallelogram DGJF. Okay. So what is the length DF? DF or GJ is equal to 2D. Okay. And HE is which is given by O2 minus O1 plus O3 by 2. So if you solve this equation, you'll be getting 2D by 3 into 2O2 minus O1 plus O2. So final area, if you substitute all these in equations, finally you'll be getting D by 3 into O1 plus 4O2 plus O3. You please don't bother about the derivation of this equation. Just try to remember the equations because it's not there as part of your syllabus, the derivations. Okay. So the area is equal to D by 3 into O1 plus O3 plus 4 times of O2. And if you extend this for n number of segments, assume that you're having now 8 segments or 9 ordinates. Here you please don't confuse between the segments and ordinates. One segment, 2, 3, 4, 5, 6, 7, 8. You're having 8 segments, but you're having 9 ordinates. 1, 2, 3, 4, 5, 6, 7, 8, 9 ordinates. Okay. So if you extend the above equation to 8 segments or 9 ordinates, the equation will be d by 3 of O1 plus O9 plus 4 times of O2 plus O4 plus O6 plus O8 plus 2 times of O3 plus O5 plus O7. O1 and O9 are the end ordinates. O2, O4, O6, O8 are the even ordinates. O3, O5, O7 is the odd ordinates. So the equation, the statements comes as to the sum of the first and last ordinates, add 4 times the sum of even ordinates and twice the sum of odd ordinates and multiply the total sum by 1/3 of the common distance d to get the total area. This is the statement of the Simpson's rule. So in the trapezoidal rule, what you are going to do? In the trapezoidal rule, area is equal to the average of first and last ordinates plus simple sum of the medium ordinates in between ordinates. Okay, but in Simpson's rule, it is area is given equal to sum of first and last ordinates plus 4 times of the even ordinates plus 2 times of the odd ordinates multiplied by d by 3. Okay, but there is a limitation in the Simpson's rule. Simpson's rule can be applied to only even segments. Okay, sorry, even ordinates. Okay, if you have odd ordinates or odd segments, then you need to apply the Simpson's rule up to the last but one ordinate or last one segment, and the final segment you need to determine using your trapezoidal rule or average ordinate rule. Then you need to add both in order to get the final area. Okay, we'll try to solve some problems and you'll be able to better understand it. Okay, take down one question. A series of offsets were taken. A series of offsets were taken from a baseline. A series of offsets were taken from a baseline to a curved boundary line, to a curved boundary line to a curved boundary line at intervals of 10 meters, at intervals of 10 meters, at intervals of 10 meters, the following order, in the following order. Write down the values 0, 0, comma, 2.68, 2.68, comma, 3.64, 3.64, comma, 3.7, 3.7, comma, 4.60, 3.62, 4, 4.84, 4.84, and 5.74. Just noting down here 0, comma 2.68, comma 3.64, comma 3.70, comma 4.60, 3.62, 4.84, 5.74. These are the ordinates. Okay. A series of offsets were taken from a baseline to a curved boundary line at intervals of 10 meters in the following order: 0, 2.68, 3.64, 3.70, 4.6, 3.62, 4.84, 5.74. Compute the area using Simpson's rule and trapezoidal rule. Okay. Compute the area using Simpson's rule and trapezoidal rule. Okay. First, let us try to draw a diagram. Drawing a diagram is not required for you in solving the problem. Just for explanation purpose, I am giving you. I'm just showing this as 0 as a small line because, or I'll show it with a dot. 0. So this is how the area is, and I want to determine what is the area enclosed between this boundary. Okay. I want to determine the area enclosed in this between this boundary, and I have taken the offsets or ordinates at 10-meter intervals. So all these intervals is 10 meters. And this value she has given us, this is 0, this is 0, and this is 2.68. And this is 3.64, 3.70, 4.60, 2.62, 4.84. This is 5.74. Okay. So this is the given information, and I want to determine what is the area enclosed within this boundary using Simpson's rule and trapezoidal rule. So first tell me how many offsets are there? How many offsets are there?
8 offsets, sir.
This is one offset, 2, 3,
8, sir.
4, 5, 6, 7, 8. But what is the condition of Simpson's rule? Simpson's rule is not applicable directly because of the area offset. So use the Simpson's rule only up to 7 offset because it is applicable only to odd offsets or even segments. Okay. So apply Simpson's rule only up to this point. This point. Okay. Then determine the area from 0 to this point and determine the next area of between these two and use sum of those two. We'll be getting the total area. Okay. So let us first take the first segment. What is area 1? Okay. Area 1 is equal to, what is the equation? E by 3 multiplied by, what is Simpson's rule? O1 plus
O1 plus
ON
divided by 2.
no plus
Plus
2
4
times
into
of,
even odd.
here we are having, we'll take up to O7 plus 4 times of O2 plus O4 plus O6 plus 2 times of odd ordinates are
O3, O5.
O3 plus
O5.
O5. So this is the equation up to 7th segment, okay, or up to 7th ordinate. So what is the value of D as given? 10 meters he has
10,
given. 10
sir.
divided by 3. What is O1 value?
0, sir.
0. Plus what is O7 value?
4.84.
4.84 plus 4 times of, what is O2 value?
2.68.
2.68. What is O4?
3.70.
3.70. What is O6?
06. 3.62.
3.62 plus 2 times of O3.
3.64.
3.64 plus O5.
4.60.
4.60. So please tell me the answers.
Two not 4.4, sir.
204.4. What are the units?
Meter square.
Meter square. Okay. You all agree? You got the same value?
Yes, sir.
Okay. A2. I want to determine what is the area between these two segments, 4.84 and 5.74. Okay. So this is equal to 10 divided by 2 into 4.84 plus 5.74. What is the answer? I am taking the average ordinate. 10 by 2 into 4.84 plus 5.74. What is the answer?
52.9 meters square, sir.
52.9 meters square. So total area is equal to 204.4 plus 52.9. What is the answer?
257.3 meters square.
257.3 meters square. What about others? Did you get the same values?
Sir, same value, sir.
Okay. Both of you are from laterals who are responding to me.
Sir, civil.
Lateral అంటే, sir.
ఇద్దరు lateral
కాదు సార్ నేను సివిల్ అంటే ప్రీవియస్ బ్యాచ్.
Previous batch. What's your number?
సార్ 23 సార్ వేణుగోపాల్.
Okay, regular అని చెప్పు. Previous batch అంటే ఏంటి?
ఎస్ సార్ రెగ్యులర్.
Okay. So this is how you need to determine the area using Simpson's rule. Okay. So the basic limitation you need to remember, Simpson's rule is not applicable when there are even offsets.
Yes, sir.
Okay. Now let us try to determine the area using trapezoidal rule. So what is the equation of trapezoidal rule? Area is equal to
3/2.
P multiplied by
First offset into first offset
O1
plus
plus
last offset.
ON by 2 plus O2 plus O3 plus
So
O4
on up to ON
so on
minus
up
1.
to ON minus 1. Okay, this is the equation. So in our case, what is the value of B?
10.
10. Okay, multiplied by what is O1 value?
0.
0.
0 plus ON is
5.74.
5.74.
5.74 divided by 2. Okay, plus O2 value is 2.68 plus 3.64 plus 3.70 plus 4.60 plus 3.62 plus 4.84. Tell me the answers.
259.5 meters square, sir.
259.5 meters square. What about others? అంటే వచ్చిందా? $23.
Sir, yes, sir. 259.50.
Okay. So this
Yes,
is
sir.
how you need to determine the trapezoidal rule. So one point you need to keep it in mind, even if the first ordinate or first offset is 0 meters, you need to consider that in the calculations. Okay. ఇక్కడ 0 ఉంది కదా, you should not ignore that it is 0. You need to consider this also while you are doing the calculations. Okay. So let us try to do one more problem.
Yes, sir.
We are having time, right? Okay. The following offsets were taken from a chain line. The following offsets were taken from a chain line at regular intervals of 5 meters. At regular intervals of 5 meters. 2.72, 3.46, 5.23, 6.80, 4.86, 3.35, 3.00, 2.50, 1.60. At a regular interval of 5 meters. These are the ordinates. P is equal to 5. Determine the area included. Determine the area included between the chain line and the boundary. Between the chain line and the boundary by trapezoidal rule and Simpson's rule. By trapezoidal rule and Simpson's rule. Who is this Sean Sundar? అటెండెన్స్ తీసుకునే టైంకి వస్తున్నారా?
క్లాసెస్ సార్.
అదే అటెండెన్స్ తీసుకునే టైంకి వస్తున్నారు. Yeah, these are the ordinates, given ordinates, and the distance between two ordinates is 5 meters. To determine the area included between the chain line and the boundary by trapezoidal rule and Simpson's rule. Okay. I'll write this in this fashion. This is O1, O2, O3, 4, 5, 6, 7, 8, 9. So how many segments are there?
9 segments, sir.
8 segments.
Draw the diagram only for your understanding purpose, but in the exam there is no need to draw the diagram.
Sir, answer చెప్పాలా?
Answer?
156.8 meter square, sir.
I'm not writing the values here. This is O1. Okay. And this is O9. Okay. Yeah, tell me the answers. As per which rule you are saying, Amma?
Trapezoidal 156.8 meter square, sir.
Trapezoidal rule. Area is equal to 5 multiplied by O1 is 2.72 plus 1.60 divided by 2 plus 3.46 plus 5.23 plus 6.80 plus 4.86 plus 3.35 plus 3 plus 2.50 plus 1 on there. Okay. So tell me the answer now.
One 156.8 meter square, sir.
It all చెప్పండి అమ్మా ఒకసారి ఆన్సర్ నాకు.
156.80 meter square, sir.
Okay. Then apply Simpson's rule.
158.23 meter square, sir.
Simpson's rule. Area is equal to 5 by 3 multiplied by O1 is 2.72 plus 1.60 plus 4 times of even ordinates. Even is 3.46 plus 6.80 plus 3.35 plus 2.50 plus 2 times of odd ordinates is 5.23, 4.86 and 3. What is the answer?
One 158.23 meter square, sir.
8.23 meter square. With all
Yes, sir. Same.
same. Okay.
Yes, sir. 158.323.
So this question comes for 5 marks.
Okay, sir.
So I'll give you one example, one question as an assignment. Try to do it. Okay. The following perpendicular offsets were taken from a chain line. The following perpendicular offsets were taken from a chain line to an irregular boundary. To an irregular boundary. The following perpendicular offsets were taken from a chain line to an irregular boundary. Okay. Calculate the area between chain line boundary and end offsets. Calculate the area between chain line and boundary, sorry, chain line boundary and end offsets. Please try to solve this. Number 1,
Present, sir.
2,
Present, sir.
3,
Present, sir.
4,
Present, sir.
6, 6, 7,
Yes, sir. Present.
8, 8,
Present, sir.
9,
6 present.
Yes, sir.
10,
Yes, sir.
8, 8, 9, 10, 11,
Present, sir.
15,
Present, sir.
16,
Present, sir. 16.
17,
Present, sir.
19,
Present, sir.
23, 24,
Present, sir. 23 present.
27,
Present, sir.
28,
Present, sir.
29,
Present, sir.
30,
Present, sir.
Present, sir. Mic problem.
32,
Present, sir.
35,
Present, sir.
37,
Present, sir.
38,
Present, sir.
41,
Present, sir.
42,
Present, sir.
44,
Present, sir.
45,
Present, sir.
47,
Present, sir.
49,
Present, sir.
51,
Present, sir.
53,
Present, sir.
55,
Present, sir.
56,
Present, sir.
57,
Present, sir.
58,
Sir, yes, sir.
301,
Present, sir.
302,
Present, sir.
303,
Present, sir.
304,
Present, sir.
305,
Present, sir.
306,
Present, sir.
307,
Present, sir.
309, 308,
Present, sir.
Present, sir.
309,
Present, sir.
310,
Present, sir.
311, okay. Bye for the day.
Sir. Please show the
Thank
question
you,
once
sir.
more.
Sir, question you present, sir.
ఒక్క నిమిషం ఒక్క నిమిషం.
సార్ ఈ నోట్స్ పీడిఎఫ్ క్లాస్ రూమ్ లో పెట్టరు సార్.
పెడుతున్నాం టాపిక్ అయిపోయినాక చేస్తాం.
Sir, calculate the area of
Calculate the area between chain line, boundary and end offsets.
సార్ నిన్నటి అంటే ఈ వీక్ లో జరిగిన అన్ని వీడియో సెషన్స్ పెడతారా సార్ మీరు వీడియో రికార్డింగ్స్?
Video recordings, huh?
సార్.
Okay, I'll update. Actually, yesterday I kept the PPTs and scanned notes in classroom.
సార్.
You want video lectures? I sent because problem అవుతుందంటే video lectures download చేయడం ప్రాబ్లం అవుతుంది.
సార్ సార్ అంటే
డ్రైవ్
నిన్న
లిమిటేషన్ 15 GB ఉంది కదా.
సార్
ఒక పని చేస్తాను. Do you have a group mail?
ఎస్ సార్
You send me the group mail. I'll forward all the mails to you. Recording.
ఓకే సార్
So you need to log in through your official ID. Then you'll be able to access.
ఓకే సార్
Okay.
ఓకే
Yeah.
సార్
Send me the message.
సార్ అలానే సార్ అంటే నిన్న అర్థమెటిక్ మెథడ్ ఉంది కదా సార్ అర్థమెటిక్ క్యాలిక్యులేషన్లో అక్కడ మనం లాస్ట్కి 30 ఎందుకు తీసుకున్నాం సార్ అంటే మిగతా దాంట్లో 15 అలా అని తీసుకుని లాస్ట్కి 30 అని ఎందుకు తీసుకున్నాం
ఇక్కడ ఒక్క నిమిషం. ఇక్కడ
సార్ అక్కడనే సార్ అక్కడ కింద therefore the horizontal distance between A and 26 meters contour
30 meters is the distance between A and B.
A and B సార్ ఓకే
ఇక్కడ చూడండి.
సార్
So 30 meters కి 2.09 meters of elevation difference ఉంటే, sorry, 2.09 meters elevation difference కి 30 meters ఉంటే 0.55 meter elevation difference కి ఎంత distance?
ఓకే సార్
Okay.
అండర్స్టూడ్ సార్
And next week also, I think mostly CSVS sir will not take class. Okay. Please don't call him once again.
ఓకే సార్
Sarana?
సార్
Okay, because he has some. ఏం లేదు, అందరికి తెలిసిన విషయమే. సార్ వాళ్ళ ఫాదర్ ఎక్స్పైర్ అయ్యారు. సో ఈస్ నాట్ ఇన్ ఎ పొజిషన్ టు టేక్ క్లాసెస్ రైట్ నౌ టిల్ నెక్స్ట్ 10 days. ఓకే.
ఓకే సార్
రైట్. బై.
బాయ్ సార్